Cybersecurity is facing a huge challenge right now. And a lot of that challenge we've brought on ourselves. In this talk, we're going to tackle the DevOps cultural shift and the role that security plays within that shift. So this is really about building a bridge between development and security. And by development, I really mean the rest of the organization and the security team. But first, we need to make sure that we're all on the same page. The term DevOps has been thrown out there for a while now. It's been used in all sorts of different definitions, but let's clarify. DevOps started to be a term itself a number of years ago with the release of this phenomenal book called The Phoenix Project. Now, The Phoenix Project is actually a novel. It's written in story style, and the main hero kind of goes through asking all these questions that most people assume they know the answers to, but the way it's phrased is really like, hey, why are you doing this thing like this? Why aren't the developers talking to operations? Why aren't people working together? And because it was framed this way, because it was written as an actual story, it really started to pick up steam. The team that built this book, that wrote this book out, did a phenomenal job in positioning it. In fact, they've continued to work together and develop other material like the DevOps handbook. Beyond the Phoenix Project is the transcript of a bunch of audio series of conversations reflecting on the Phoenix Project. And the latest book of Accelerate try to put a little more rigor around these different processes. But the idea is this genesis started out there of saying, hey, there's probably a better way to work. One of the main challenges we're facing, though, is that the terms DevOps has been taken by marketing, by sales, and as much as I love those teams, they have used and abused this term so that it's beaten beyond all meaning. So that's why we're clarifying here. Exactly what do we mean when we're talking about DevOps? Well, the folks at Gartner have a very long and verbose definition, and in fact goes to a whole nother slide, which I'll show you in a second. But the key part is here, right out of the gate, they call out the fact that it's a cultural shift. It's a cultural change. And you can see their definition just keeps on going. But it does cover the main points. Here's Microsoft's definition. I like Microsoft's because it calls out the 3 Ps. It calls out people, process, and products. And from a security perspective, you can't have strong cybersecurity or strong information security without addressing all 3. You can't ignore people and just focus on products or process. You can't just buy products and ignore process and people. You can't just focus on people and ignore process and products. You need all 3, which is why I like this definition. And Microsoft actually visualizes DevOps in this sort of the infinity donut. You'll see this quite often where you have development on the left-hand side where you're coding and you're building and you're pushing that continuously deploying and integrating it out into production on the right side where you're monitoring and learning and pushing feedback back into the left-hand side. And I like how smooth this process is. It's extremely ambitious when it's drawn this way. I find it very aspirational. Here we look at AWS's definition. Again, it's a little bit wordier, but they too hit on the fact that this is cultural, that this is not just involving people and products. They have a far more pragmatic way of visualizing it. Here you can see the back and forth of sort of just straight out structure of we're going to build and test, and we're going to push it in production, we're going to monitor and push some feedback back the other way. My favorite of all time, though, comes via Sonia Gupta, who was quoting Jeffrey Snover from Microsoft Build Conference in 2018. And basically, you know, it's a way of breaking down silos and stopping being a jerk to your coworkers. And I think that's a critical piece. It's doing shorter feedback loops, but working together, breaking down those silos. And really, again, you can see time after time after time, we're hitting on the cultural piece. And that may make some people very uncomfortable because culture and people work is difficult. The soft skills are not normally where we concentrate when it comes to information security. So speaking to the security folks out there, let me give you my definition of DevOps from your perspective. Okay, I very much agree with all those definitions I just showed you, but I want to give you a security-focused definition of DevOps. It's a culture of collaboration that focuses on reducing risk by making smaller changes to production. That's it. Nice and simple. It's a culture of collaboration, working together, breaking down silos, that focuses on reducing risk, so making sure that stuff works and works well and doesn't have any security issues, by making smaller changes to production. Now, that's where a lot of security folks get hung up, because those smaller changes to production necessarily facilitate more changes to production, faster changes to production, a more dynamic environment. But I think that's an overall positive because it does reduce risk. Now, I know what you're thinking and saying, wait a minute, security in DevOps, don't we already have a thing? Stop, Mark. Let's tackle DevSecOps. I'm trying to hold my face as nice as possible because my answer to that is simply just no. No. DevSecOps is not a thing. It's the height of security arrogance to try to co-opt something that's already out there and a cultural change underway to say, no, you need to insert security into this. I will be honest and open with you and tell you right now that outside of the very small percentage of actual malicious insider threats, people who have full intention of breaking systems and stealing data or resources from the company they work for, no developer sets out to write bad code. No developer says, you know what, I'm going to go in and work today and I'm going to write a huge amount of security vulnerabilities and yeah, that's going to make everybody's life better. Nobody thinks about that. Nobody puts that as their to-do list, right? Same with operations. Nobody says, you know what, I'm going to change all my passwords to password because that'll make everyone's life easier and it's a brilliant idea. This is not the goal. People's goal is to do their work and do it well. Most security issues come from honest mistakes. So for us to come in and say, wait a minute, this DevOps thing is beautiful, it's a great initiative, we're going to make it DevSecOps because we're super important. That is very arrogant. I don't like it. No. To the point where friends of mine, Raf and James, they had me on their podcast to talk about this. And we actually titled the episode, DevSecOps is not a thing. It's just not a thing. DevOps is a thing. Jump on board with that. Because remember, the goal of cybersecurity is to make sure that your systems work as intended and only as intended. Now, that's a different definition for a lot of folks about cybersecurity, but I think it's a very, very useful one because you can't do this alone. You can't make sure that your systems work as intended and only as intended just by being an isolated security team hiding away in your office, in your SOC, only monitoring security tools around a strong perimeter. You may say, hey, we're super cool. We go do threat hunting. And you know what? Threat hunting is a valuable activity. But if you leave systems unpatched for months, if not years, threat hunting does you no good as an organization. It's a vanity metric. It makes your security team feel well. Security is a team sport. Get on board. This definition forces that. So let's take a look at the developer workflow. We already introduced that sort of the donut, right? And AWS had the back and forth. Essentially, you've got two camps here that make up DevOps. You've got development and operations, and there's not a hard line between them necessarily. Unfortunately, there still is in some organizations, but these are the general activities that have to take place. On the left-hand side, we've got development. We've got to plan, we've got to code, we've got to test, we've got to stage things to get them ready to run over in production. And in production, when we're running them, then we need to detect any issues, respond to them, and mitigate them. And of course, you're pushing innovation this way, and you're learning and pushing feedback back into the development cycle. And in an ideal world, this stuff kind of runs nicely, right? Like it's going to spin and we're going to see these wheels working in synchronization. And that's where I always get a chuckle out of the infinity donut because you know what? It's never that smooth. I like to see it in its chunky native form in the boxes. So you can see on the left-hand side here, we've got each stage individually called out for development, push it over to production as a deployment, and then we have the 4 stages in production for monitoring. Now, security folks, we're extremely comfortable on the production side of the house. We know how to deploy security controls to protect production environments, to monitor them while they're running, to detect and respond to issues and to mitigate those issues. Where we are not comfortable is over on the development side. So get over there and start doing some work because it turns out it's way cheaper and more effective to do security on the left-hand side than it is where we do it right now in production. Now, this slide comes from NIST, and it basically says, in the planning stage, your cost is 1, right? This is if you never wrote a security vulnerability or had a security issue, your cost to fix it is essentially the baseline here. We're gonna set that at 1. And as we move, you see it's worse and worse. It gets more and more expensive. It gets 5, 10, 15, 30 times more expensive. Now, right now, today, the vast majority of security work goes on in the 30 times column. We are spending way more than we need to mitigate security issues because we're not worried about the other stages. We're not working with those teams. We're not collaborating to ensure that security issues never bubble up into production. So we're actually paying 30 times the amount that we should in time, in actual outlay of money, and just in effort and stress than we should be. Here's another way to look at that. That's the same chart, just sort of flipped on its side, so we can see the money impact as we go. Now, a while back, Kent Beck, who's extremely popular, extremely wise development guru, has been doing this forever, has really advanced the state of development over the last few decades. He had a postulation that said, you know what, hey, if we reduce the feedback loops, if we do things faster, we'll probably reduce the cost to fix software errors. And he was talking purely about software development here, but it applies equally to security. Don't we want to save money? Don't we want to make this easier for ourselves? So not only do we have to move into the development phase, but we also have to make sure that that development phase is going faster. We want things to move as fast as possible in security, not because we think that's going to necessarily solve all our problems, but it makes the problems smaller and it makes them cheaper to address. And that makes a lot of folks very uncomfortable because it runs opposite of the normal security thinking, which is stability, don't mess with things. Well, we do want to make sure that the business is enabled and keeps moving, but we want to make sure that those changes are small and measured and we know about them ahead of time. The way we do that is through this movement, through this term called shifting left, moving over that way into the development cycle. So let's talk about those each really briefly and give you a couple ideas. When it comes to planning, that's the first phase of a development sprint. The reason why it's important for security to get involved right at the start is simple. The way that we've implemented security today in our organizations doesn't work at scale. We know this because there's been claim after claim about a cybersecurity skills gap. And don't get me wrong, there's a massive gap in skills. And all the efforts we're doing around training more people, focusing on more certification programs, focusing on sort of cybersecurity accelerators for education, small university programs, working with colleges and universities around the world. These are all great things. We know there's going to be up to 2 million jobs over the next couple years that are open and we're unable to fill. There's essentially negative unemployment in cybersecurity. As a cybersecurity pro, this is a fantastic thing. There's always job opportunities. As a cybersecurity professional who cares about making everyone more secure, this is a massive issue. But we're ignoring a huge potential resource. So all of our efforts have been focusing on creating more pipeline of cybersecurity folks, but we're ignoring everybody around us. And this is a huge short-sighted fall. This is where we've fallen down, and it's a failure on the security community because it's our role within our organizations to be educators. We need to educate everybody around us to move the level of cybersecurity knowledge up. We need to help everybody understand the context in which they're working, to understand the risk environment, to understand the organization's appetite for risk. Because again, outside of a very small fraction of people who have malicious intent, everyone within your organization is trying to do a good job. Just help them. That's our role. We need to step up and educate. So let me give you an example. This is based on some numbers from Gartner as far as breakdown of organizational structure. So here's everybody in your organization. It's a nice bunch of folks, and they're all trying to do their job, whether that's create widgets or whatever your company is trying to do. Now, on average, out of all these folks, here's the 3 people who are going to be doing IT work. Now, this includes your developers, this includes operations, this includes the help desk. This is everybody associated in an IT role. Okay, now they're supporting everybody else. That's quite a lot of work. Now, here's the cybersecurity breakdown. It's just this little part of a head. That's it. That's the average breakdown. That's insane. That little part of somebody's head is supposed to protect absolutely everybody else. This is how we've set up our organizations. Instead of trying to raise everybody else up, we're isolating the cybersecurity knowledge. And this is a massive, massive problem. Now, these numbers actually break down and they hold up pretty consistently. For every 756 employees, we've got 1 that's focused on security. We have 50 that are focused on IT, but just 1 that's focused on cybersecurity. Now, wouldn't it make more sense for us to lighten our workload by, at the very least, getting the other 49 folks that are in IT on board with the security program? Doesn't that seem reasonable? Let's focus on that. And you can start really, really simple. Here's an example, because there's many ways to tackle this. I'm going to suggest this one because it's a fun way, yes, nerdy fun, but still fun, to get involved in the planning cycle when it comes to development. And this includes a basic planning for operational work as well that doesn't include custom development. But this is a game from Microsoft. It's available in a Creative Commons license, which means you can freely download it, print it, and play it, work with it. It's called Elevation of Privilege. And instead of having normal suits like hearts and clubs and diamonds and spades, they have attack suits like elevation of privilege, like spoofing, that kind of thing. And each of these cards, the way the game works is very similar to kind of like a hearts style game. And you work through thinking of like, hey, okay, if somebody has elevated privilege and runs this function, what happens? If somebody spoofs the input to this function or sends bad input, what happens? And the whole point of this card game is to enable a discussion within your development team so that people start to work through some of the cybersecurity problems. It's a fun way to help raise everybody's knowledge, because the more you play it, the better you get at asking these questions when you're planning out your development before you've even written the code. Which brings us to the next step, code. Right? Now, this is the vast majority of custom development is actually done writing code. And I'll give you a secret. I've been writing code for 25 plus years. Many people in the industry, the one consensus we do have around code is that code quality is a massive problem. We don't know how to fix it, but we know it's a problem. So here's an example. This is the OWASP Top 10. This is the application, web application vulnerabilities. Started in 2010 with the first published version. The work started a little earlier. So basically for a decade, we've been tracking what the most common web application issues are from a security perspective. And you can see here the top 10, injections number 1, and then there's a list of others that are very common. We talk about these quite often. When we did an update to the list midway through the decade, you see here that things moved around a little bit, and there's a couple new things indicated by stars, but those are really just expansions of existing terms, and of course injections still sitting at number 1. Late last year there was a finalized update, and again, a few things expanded and got new names, but injection continues to be number 1. This is ridiculous. It is absolutely ridiculous, because in every single programming language for every major framework out there, there is a freely available, open source, well-supported input sanitization library that people just apparently don't use enough. Now, the input sanitization library helps prevent injection attacks. Yet people insist again and again on writing their own. And this comes not from an arrogance. It doesn't come from any malicious intent necessarily. It comes from a lack of education and awareness, one that we can solve as security folks by moving in earlier in this phase and helping, right? So shortening feedback loops helps with code quality, helping systems enforce process. So making sure that that CI/CD pipeline that keeps this rapid flow has systems that are enforcing various processes, and working together is really the best way to help increase code quality. But there's no easy answers here, but the work needs to be done together, because at least making the effort is going to see some improvements. Where security is far more comfortable these days is actually in testing. One of the biggest issues when it comes to application is application security is third-party dependencies. I'll give you a quick example. In the Node.js community, extremely popular web framework, there was an issue a couple years ago with a library. For some reason, people wanted a library that helped them left pad strings. So instead of having just a 1 and then a 10 for the next string, you do 0, 1 so that it looked really nice. Very common, it's a nice aesthetic, but instead of writing that function, which is ridiculous, it's only a line of code, you should just write it yourself, people were pulling in a library from NPM, from the main package distribution. And what happened was somebody got grumpy, there was some challenges as far as on the social side, and the author of that package actually yanked the package out. So now everybody who was trying to build their application, it just failed. It failed outright. And from a security perspective, that's actually the best outcome, because at least you knew there was a problem. Most people, though, their apps died and they weren't sure why, because of third-party dependency. This is a video that illustrates some of these challenges here. You'll see as it grows out, these are the one library, and all the white dots are actually additional libraries. So your developers write one import statement, and then what ends up happening is that all these other libraries are pulled in automatically, because they're all dependent on, the main library is dependent on these ones. Now the issue is that any problem in any one of these dots is a problem for your application. how much are you looking at the code that are in each of these? Now, don't get me wrong, pulling in other libraries is wonderful. That's how we build better applications, is by building on the work of others. But look at how many libraries I've pulled in just with one import statement here, right? Now, some of these are examples, Browserify and Gulp are examples of stuff that shouldn't be in your production application, but they end up in production on your systems non-stop. We see it all the time out there. So we have hundreds of dependencies here. This is going to be even more. Here comes Gulp. You're going to see this is a massive, massive web of interconnectedness. Now, any issue in one of these is an issue for your application that you need to be aware of. So the good news here is that from a security perspective, we can set up scanners, we can set up automated systems to look for these vulnerabilities and help to actually mitigate them so that we know that we're aware of them. So you can see here 181 dependent libraries, and there's actually interconnected. That's the 220 number actually is the interconnection between these libraries, not just with the one that you've imported. So GitHub, who has done some great work in 2017, where they're highlighting known vulnerabilities on repositories that import those additional libraries, and that's a very, very positive thing. But from a security perspective, here's a great place we can jump in. We can add automated vulnerability scanning, automated configuration management. At the same time, we should be adding some unit tests for security. Developers are very comfortable writing tests for their code. So if you have a TPS report generating function that takes dollar signs, dollar amounts coming in, what happens if you give it a string instead of dollars? What happens if you give it a really big dollar, a really small dollar? That's a basic unit test. For security, we should be doing the same thing. If you configure a firewall, you should have a test that pings the firewall and all those ports that you expect to be closed to see if they're closed or not. Same with the open ports and basic testing like that. And this helps us at this stage working here to map out the known issues around the application, to map out how the application is supposed to behave. Because if we know how it's supposed to behave, that helps us in the next stage, and that is the staging stage. Here's where things get ready to go to production, right? Everything's tested, all the tests have passed, or at least passed to a level that you're comfortable with. You've mapped out any known issues so you can start to mitigate them. That means you have a blueprint for how this application is supposed to work. From a security perspective, we should be taking this blueprint and moving that into our production defenses. So we need to be able to mitigate any known vulnerability. So if we knew there was an issue with, I don't know, let's say Apache Struts 2, we could mitigate it with an IPS rule here, as opposed to just blindly accepting the risk. Because we've mapped it out in the earlier stages, now when we're staging about to move to production, we know what kind of rules we need in place for our various security controls. We can also increase monitoring on those areas to ensure that we're not leaving ourselves vulnerable to anything unexpected, because we know what changes there, and we can quickly identify any issues that do pop up, because these are smaller changes. Instead of pushing out 30,000 lines of code or even 3,000 lines of code to production, we're making changes of like 3 lines of code. It's a wonderful thing from a security perspective. So you can see the advantages of moving earlier, of shifting to the left. Moving earlier into this process give us a significant advantage when it comes to security, not only cost, effort, and stress level, but we're getting better information. We're able to do our jobs much, much better. But the challenges are still there. There are a lot of people-based challenges. Security not scaling, quality, making quality software, facing external pressures. These are all people pressures. I yearn for the days when everything was just technical, when you could actually sit there and say, well, 2 + 2 is in fact 4. The technical side works out really nicely. How to figure out the people? I'm not going to lie to you. That is really, really hard. But if we start to change how we approach security, if we start to teach others, if we start to shift security into the left side of the development process, if we start to break down those silos, we're going to see an absolutely massive increase in our security posture. We're going to see way more security wins. We're going to be happier at work too, which is an awesome, awesome thing. Because remember, DevOps really is a way to reduce risk through collaboration by making smaller changes into production. I think this represents the biggest opportunity that security has had in a very, very long time. If we can jump on board with this cultural shift, we can actually align the implementation of security with our desired outcome. And that's something that's been missing for a very long time, because we've been too busy fighting fires to step back and realize that we can change the way that we implement security. Because remember, our goal here is to make sure that our systems work as intended and only as intended. Thank you very much. Let's keep this discussion going. Hit me up online. I'm Mark NCA, or in the comments down below, because I think this is really the start of something. It really needs to be about a discussion. Soft skills, culture change, this is hard stuff. This is stuff that our community is not used to dealing with. Let's work together. Let's keep an active and open and honest and frank discussion, a positive one that's very supportive, and maybe we can all help each other have better security outcomes. Thanks for taking the time to watch this video.